Here we have our formal definitions of partial derivatives. The partial of f with respect to x at the point x naught, y naught. Well, the partial with respect to x is treating x like it's the variable and y like it's constant. So I see I've just plugged y naught into my function with no change, no increment. It's always just y naught. Well, if I treat that as a constant, then this is really just a function on x, and I'm really just taking a derivative. F of x naught plus delta x minus f of x naught all over delta x. Take the limit as delta x approaches 0. In our Calc 1, we usually use h in place of this delta x's, but it's always just been a change in x. The partial with respect to y, I treat x like it's the constant x naught, and I do the derivative in the y direction. We can actually use these definitions just like we use the definition of derivative in Calc 1 to evaluate derivatives. And in fact, I might have to if I don't have a rule for something. If I do have a rule for something, though, I should use that. So let's look at this example. F of xy is the function on two variables, x cubed minus 9xy plus y cubed. We're told to find the slope of the curve formed by intersecting z equals f of xy with the plane x equal 3 using a partial derivative in when y is equal to 1. Well, the instructions to use a partial derivative are important because it gives me the method I'm going to use. Because one viable strategy here, since I know all the x's are equal to 3, is to plug that in and take a derivative as if this was just a function with respect to y. Whereas to do the more general thing, come up with a formula that I could then, think about other planes or other values of y. Okay, well, I'm always in the plane x equals 3. X is a constant. I need to take a partial derivative with respect to y. So I need to differentiate, treating x like a constant. So x cubed is a constant, derivative of a constant is 0. I have a constant, minus 9x times y, so the derivative of that term is minus 9x, and then finally plus 3y squared. To find the requested slope, I have partial of f with respect to y, but evaluate at the point, well, I'm in the plane x equals 3, and I was curious about what happened when y was equal to 1. So I just plug in. So I have minus 9 times 3 is minus 27. Plus 3 times 1 is 3. That slope is minus 24. Whatever this graph is doing when I intersect it with the plane x equals 3, the tangent line at y equals 1 has slope of minus 24.